street after street after street. Nearly the entire community of Pacific Palisades has been destroyed here over the past couple of days.
Exactly 1 year ago, the horrific Los Angeles wildfires displaced over 200,000 people while killing almost 500 innocent citizens. Sadly, this is not the only case of devastating wildfires happening across the country. Every year, wildfires destroy millions of acres of land, displacing families and costing billions of dollars in reparations. Yet, many communities still rely on old-fashioned reactive systems in order to tackle wildfires. Even worse, most cities, just like LA themselves, face extreme worker shortages and a lack of meaningful wildfire prediction resources.
So what if we could identify high-risk wildfire zones before a fire starts using artificial intelligence and data that we already have? In the United States, wildfire systems detect fire after they've been ignited, and this is from satellites from outer space. However, this is really inefficient because it wastes millions of dollars and it needs thousands of personnel to maintain this.
On top of that, the AI systems that some cities use are wildly inefficient and cost-heavy. Overall, fire departments and local governments often lack affordable tools that help them anticipate wildfire risk and allocate resources proactively. In Texas alone, over 10% of citizens live in poverty, unable to proactively predict wildfires for cheap. As a result, we created the Forest Ignition Risk Evaluation System, or FIRES, an AI-powered wildfire risk prediction system that analyzes geospatial satellite data to estimate wildfire risk through known satellite images. Here's how it was created. First, we downloaded over 40,000 verified satellite images of forests that have previously experienced wildfires, all of which were compiled from the Government of Canada. And we split the data into 3 sections: train, test, and validation, before pre-processing all the data by ensuring every bit of non-numeric data was converted into a number corresponding to its value. Finally, we trained 3 machine learning models: a multi-layered perceptron model, a random forest model, and a k-nearest neighbor model, all on the training data. The multi-layered perceptron model had the highest training accuracy of almost 96%. As a result, we tested the validity of this percentage by testing the multi-layered perceptron model on unseen test data, where it proved itself with an even higher accuracy of 96.7%, with significantly less appearances on false positives.
FIRE's consumer-based platform helps consumers, environmental organizations, and governments to better figure out if there are wildfire risks around the area by cross-checking the images through the system.
Here is how the FIRES pipeline works. First, the system processes satellite and aerial images that can be inputted by the user. These inputs are analyzed by a highly complex multi-layered perceptron model, custom trained on tens of thousands of verified forestry images from the Canadian Wildlife Association.
Instead of producing a complex technical output, the model delivers a final and easy to understand result. A yes means that there's a high probability of there being a wildfire, while a no is a low risk of there being a wildfire.
The website then gives useful tips that the consumer can apply to the land based on the results given by the model. As a whole, FIRES is designed for 3 main groups. One being individual landowners and residents in wildfire-prone areas, the second being environmental and non-profit organizations monitoring forest health, and the third being local governments or fire departments that lack the budget for advanced protection tools. Rather than replacing existing response systems, FIRES acts as a preventative layer, helping users accurately identify high-risk areas before ignition. In addition, most wildfire risk assessments and modeling tools cost upwards of $100,000 per year for a single county, with some satellite-based systems costing millions once hardware, imagery, and personnel are included. FIRES, by contrast, runs entirely on public satellite imagery and cloud-based inference, allowing wildfire risk analysis to run for under 5 cents per image, meaning thousands of land assessments can be performed for well under $1,000 annually, making proactive wildfire intelligence accessible for underserved communities. At the same time, this cost advantage allows FIRES to be priced accessibly while still maintaining healthy software margins of 70 to 90%, which are typical for cloud-based AI platforms. For example, offering subscriptions at $1,000 to $5,000 per organization per year could generate sustainable revenue while remaining affordable for small municipalities and nonprofits. At scale, even modest adoption across wildfire-prone regions could translate into 6-figure annual revenue, enabling reinvestment into model improvements, expanded coverage, and public access program. Despite its low cost, FIRES achieves 96.7% accuracy on unseen satellite imagery, rivaling proprietary systems that are orders of magnitude more expensive. By achieving comparable performance with significantly lower expenses, FIRES is able to operate with a strong profit margin while maintaining accessibility for cost-sensitive users. It is also important to note that FIRES will ease the strain of fire departments with staffing issues by providing an initial clearing for certain areas. Thank you for listening to our presentation about FIRES, or the Forest Ignition and Risk Evaluation System. We hope that FIRES can stop wildfires across America.